Branching can be initiated during the execution of a program by transmission of the appropriate signal to the robot. In the transfer and assembly operation shown here, the robot vision system examines parts on one conveyor, and if they are the wrong size, a branch instruction is initiated which instructs the robot to place a defective part in the reject bin. If the part is the correct size, the robot arm picks up the part and places it in the workpiece located on the second conveyor. As the automobile enters the workstation, its body style is determined by a vision system, and this information is sent to the robot for selection of the proper program to be executed. When the spot weld is made, the weld control sends a signal back to the robot. The robot then manipulates the spot weld gun to the next program position and again signals the weld control. This process continues until the required welding has been completed. One common application of sensory feedback is in stacking and destacking, or palletizing, of material. The system shown is an example of a robotic system where a vision sensor is mounted on the tool with which the robot handles the parts. The robot is programmed to pick up a bag from the conveyor and place it on the pallet. The vision system on the end of the robot arm is used to determine the best position to place the bag on the pallet so that the stack does not fall over. When the robot determines the best position, it lowers the bag onto the stack and releases the gripper. This animation shows an example of a mobile inspection robot which is used to remotely inspect above-ground storage tanks which would usually contain petroleum products such as gasoline. The robot can easily travel up the side of the tank by using electromagnets to exert a small holding force. This type of inspection is necessary in order to ascertain the state of corrosion of the floors and sidewalls using video and ultrasonics. In this AI application, a robot hovers over an assembly line and examines the gears that pass underneath it for faults. If a fault is discovered, the robot lifts the gear off the line and loads it in a reject bin. Before the robot is put into practice, it is trained using a neural network to recognize the salient features of the gear, its radius, the shape of its perimeter, and its size. When the machine is then put on the assembly line, its optical equipment converts what it sees into input for the neural network.